Go ahead and start by writing down this problem and trying it to find the surface area here. Unpause the video whenever you are ready to go over it. So for this one, we want to find the surface area of everything that we can touch. So we are going to divide it into the different regions that we can actually work within. If at first I want to find the area of the top of the cone. For the cone, we cannot touch the circle. So from our surface area formula, it is originally pi r squared plus pi rl, but we cannot touch the circle. So we're not going to find that area. We are only going to do the top of the cone. So when I plug this in, it's going to be pi times the radius of that circle. It's half of 34, so 17. The slant height is the 20. Typing that into our calculator, gets you 1,068.1 meters squared, and that is just for the top of our shape. Then we're going to go through and find from the cylinder. What's important here is that we cannot touch one of the circles. So while our surface area formula is 2 pi r squared plus 2 pi rh, I only have one circle, so I'm not going to do 2 pi r squared, I'm just going to do pi r squared. When you do that, again, my radius is 17. My height of the cylinder is this 12. And again, that becomes your calculator's job. So you're going to do 17 squared times pi plus 2 times pi times 17 times 12, which gives me 2,189.7 meters squared. To get your final answer, remember you just need to add those together. So my total surface area of this shape is going to be 1,068.1 plus 2,189.7, which gives me 3,257.8 meters squared. You have the homework answers on your mind. You are welcome to go through and talk to each other and see if you have any questions to help out on those. Otherwise, feel free to come see me in ACT Lab or something like that before school, after school, to get some help. Day 4 goes over volume. You should have a sheet for your notes so that the picture's already drawn for you, but we're going to find volume of everything today. When you get your sheet, I want you to fold it in half, just like we normally do, so that your problems are on the inside. And then on the front, you're going to write volume formulas just like this, because I'm going to give you 3 different volume formulas that you're going to use throughout today based on what shape you have. Your first of 3 is for volume of prisms or cylinders. Because remember, prisms and cylinders really are the same thing. A cylinder is just a prism with a circular base. To find volume of a prism or cylinder, your volume is equal to big B, and that is important that it's capitalized, times little h. This big B is the area of your base. So whatever shape your base is, you're going to find the area of it. The fact that it is capitalized means that I need to do something to get that number, so I need a formula to plug into. The h is the height of your prism. Your second formula is going to come, and it's going to be for volume of pyramids and cones. Again, those are related. Cones are just pyramids with a circular base. And your volume formula is similar. It is 1/3 big B times little h, where the big B and the little h mean the same thing. So the big B is the area of your base. The little h is the height of your cone or your pyramid. Your cone or your pyramid. Lastly is volume of a sphere. And this one is 4/3 pi r cubed. you want all three of those on the front of your sheet. That's all we're going to write there. Then we're going to open up and try some different examples on the inside. Again, feel free to pause this video as you go through to write down everything and then keep going when you're ready. This shape here is a pentagonal or pentagonal prism. So since it is a prism, my formula is big B times little h. You use the 1/3 when it's a pyramid because it kind of tapers to a point, and you use just big B times little h when it is a prism. This big B, I'm going to go off to the side here, means I need to think of my area formula. So this shape is a polygon, which means I'm going to do 1/2 my perimeter times my apothem. So you're going back to your formulas from day one for this. And I'm going to solve for this number. So my perimeter, each side is 11, and I have 5 of them, so my perimeter is 55. My apothem is the 7.6. So I'm going to do 1/2 of 55 times 7.6, which gives me 209. So the area of my base is 209, and I'm going to plug that into my volume formula here. Then you need the actual height of your prism. So how far apart are these two pentagons? Okay, and that is this 12 right here. So the actual height is 12. And then I'm going to do 209 times 12. And that gives me the volume. So 2,508. Your volume units are now cubed. Okay, what it figured out for us is if I stacked this area of the base, the 209, 12 feet tall, how much volume would it be? And that's the 2,508. So I'm stacking those pentagons and figuring out how much space is in there. Okay, make sure that that makes sense and then go on to the next one. If it doesn't, feel free to go back and listen again. And we're going to try this one. When you're looking at this shape, this is a rectangular pyramid. Okay, the rectangular tells me that when I go off to the side and do my base, I'm going to do area equals base times height because that's the shape of that, or that's the formula for that shape. The pyramid tells me what my volume formula is. My volume needs to be the 1/3 big B times little h. So you can get a lot of what you need just from this name alone, which is why I will always encourage you to write it down. To do the area of my base then, the base has dimensions of 10 by 6. So the area of the base is 60. When I plug that in, I then need the height of the actual pyramid, which is the 12. The distance from the bottom to the top of the pyramid is 12. So then we're going to do 1/3 times 60 times 12, and your total volume is 240 meters cubed. Okay, once that one makes sense, again proceed on to this next one. When we're looking at this one, this is a cylinder, which remember is just the same as your prism. So my formula is big B times little h, and my big B is a circle. So when I go off to the side to do this, my circle formula for area is pi r squared. Remember, you're always finding the area of your base, whatever that may be. Since my diameter is 6, my radius is 3. Plugging that in your calculator, you should get 28.3. That is your big B. Remember, big B is always the area of your base. You need to do something to calculate it. So we did off to the side over here. Then the height is how far apart my circles actually are. Is this vertical? So that is my 10. So my volume, when I type that in, is 283 yards cubed. Again, feel free in this video to pause it, rewind it, do whatever you need to do. For this next one, this is a cone. which we treat the same as a pyramid. So we will use our volume equals 1/3 big B times little h. My big B is again a circle, so pi r squared. Looking at this circle, my diameter is 20, so my radius is 10. And so when I type this in 100 times pi, we will get 314. We'll round that to 2. Going back to our volume, 1/3 of my 314.2. But now we run into a little bit of a problem. This 214 is my slant height. It is not the actual height of my cone, which would be in the center. We did this a little bit with every other day that we've done so far this chapter. We are going to look at this right triangle right here and solve it to find my actual height of my pyramid, because your height needs to be this vertical straight up and down in the middle. So the 22.4 is my slant height that we talked about with our surface area. We need our actual height. To do that, we can use Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. My a and b are the x and the 10 of my radius, so 10 squared plus x squared equals 22.4 squared. When we solve this, we're doing 22.4 squared minus 10 squared, and then square rooting that answer, and you should get that your height is about 20.0 when you round it. So that is the number that we will plug in for our height. So again, you cannot use this slant height that was given to us. We have to do Pythagorean theorem to find this actual vertical height. When we plug this in then, 20 times 314.2 times 1/3, or just divide by 3. Your total volume is equal to 2,094.7, if we round to the nearest tenth, inches cubed. For your sphere, this is like with most when we talked about before, mostly just a calculator problem. Once you know it's a sphere, you know it's 4/3 pi r cubed. I'm going to plug in my radius. When you type this in, you're doing 4 divided by 3 times pi times 10 cubed. And the number you should get out of your calculator is 4,188.8 inches cubed. So do make sure that you type that in. You get that answer out correctly. We're going to do a couple composite figures. These are actually easier than our surface area ones because you're doing just total volume for each region. You don't need to think about what you can and can't touch, because with volume it's just all a total. So we're still going to number our regions the same as before. This picture should look familiar from last time. Okay, and we're going to go through and find each volume separately. So the first one is a cone. So my volume is 1/3 big B times h. This big B, and if you notice, they all have the same circular base, so I can actually find my big B up here if I want to and apply it to all of them. It is a circle, so it's pi r squared. The radius of every circle here is 2. So pi times 2 squared, or times 4, is 12.56, so 12.6. So that's the big B that I'm going to use for all of them. But you'll notice we kind of have the same problem. We need to find this height. I don't know this height. I do know the radius, so I need to find my height using Pythagorean theorem. So I'm going to do x squared plus 2 squared equals 3 squared. Which should give you a height on this one of 2.2. And so my volume of the first part, rounded to the nearest tenth, is 9.2 meters cubed. Moving along to the second one. This is a cylinder, so it's big B times h. My big B we already discussed. is 12.6 because the circle is the base is the same. This 3 is the height, so I can just do times 3. 12.6 times 3 gives me 37.8 meters cubed. And then for region 3, it's very similar to region 1. Volume is 1/3 big B times H. My big B is 12.6. My height, you will notice I have the same problem. I know the 4, but I do not know the actual height. So I'm going to do x squared plus 2 squared equals 4 squared. To Pythagorean theorem again. Take a second and get that, but you should get x is 3.2 when you round to the nearest tenth. Then typing this in, 12.6 times 3.2 times 1/3 or divided by 3 gives me 13.4 to the nearest tenth. And then my volume, you're just going to add them all together. Oopsies. So my total volume would be 9.2 plus 37.8 plus 13.4, which is 60.4 meters cubed. So you find each volume separately and add them all together. I want you to try this one and then unpause it when you're ready to go over it. For this one, I have 2 regions. I have this pyramid on top, and I have this prism on bottom. So for my pyramid, it is volume is 1/3 big B times little h. My big B is whatever the base is. Again, these have the same bases, so I can go ahead and just find big B one time. Since they are squares, it's base times height. And these are actually, again, they are a square, so it's 4 times 4 is going to give me 16. That is the big B I'm going to use in both my problems. So for this pyramid on top, it is 16 times the height. Again, we don't know it. Okay, for my Pythagorean theorem right here, what's important, if the whole side is 4, then into the center is just 2. So when I'm working to find this height, I'm doing x squared plus 2 squared equals 5 squared. And I get that my x is 4.6. So the height is 4.6 here. Take a second to make sure you get that. And then when you work it out and get your actual area, you should get, or volume, sorry, you should get 24.5 centimeters cubed for just the top of this problem. For region 2, this is a prism, so volume equals big B times little h. Again, I already know my big B is the 16 from before, since they have the same square base for both shapes. My height, so the distance from the bottom to the top, is 6. And so this one's a little simpler. You just do 16 times 6, and you get a volume of 96 centimeters cubed. For your total volume then, you will do 96 plus 24.5, and your total volume is 120.5 centimeters cubed. So again, the tricky part here is this little triangle. It is only halfway because the whole thing across is 4, and so to the center to get your real vertical in the middle there would just be 2, and then you do your Pythagorean theorem below. Last problem is this one. Go ahead and find the volume of both shapes, and then take a second to go over it in here with me. So once you are done, my first region we can take as this rectangular prism, which means I'm going to do big B times little h. You can pick any base you want here, just based on how the problem works. So say I pick this bottom, the 5 by 3. That means my big B is 5 by 3, which is 15. So I would plug 15 in for this big B right here, since that's, again, base times height since it's a rectangle. The height of the prism, then, is the distance from this 5 by 3 at the bottom to the other one at the top, which would be 7. So 15 times 7 gives me 105 inches cubed. Region 2, then, is my cylinder. Cylinders, remember, we also treat as big B times little h, but now my big B is a circle. So I'm going to do pi r squared. My radius is 2.5, so I'm going to do pi times 2.5 squared, and you should get 19.6. And that's what I'm going to plug in for my B. My height of the cylinder is the 4, that's the distance between your square or your circles. So 19.6 times 4 gives you 78. Let's see, 19.6 times 0.4 inches cubed. Last but not least is your total volume. So you will add 105 and 78.4 together, and you get 183.4 inches cubed.